Greetings, this is Artie from Artifact Electronics. In this episode, we're going to have a look at this component tester. It's an automated tester that will test 2 or 3 lead components, identify them, and based on what it thinks the component is, give you some parameters. I bought this through eBay, and it was incredibly cheap. I paid $4.61, and even though this is most likely made in China, it was shipped from the US and I had it in 3 days. So let's see what you can get nowadays for under $5. As you can see, it's got a monochrome LCD display that's backlit. So when you turn it on, it immediately goes in and tries to identify the component. The device under test goes into here. It's a 14-pin ZIF socket, but in one way or the other, each of these pins is connected to terminal 1, 2, or 3. And it gives you some permutations, so whether you have bigger or smaller components, they can be accommodated by this socket. Now you can get more deluxe versions of this, ones that have a case, a battery holder, and even test leads that are connected to the 3 terminals, which is something I regret not getting. But looking on the back of it, there it is. And I haven't even looked at the processor yet to see what that is. Let's see if I can decipher what it says on there. It's an Atmel Mega 328. Basically an Arduino, and it's interesting because I think this was developed by an individual in Europe originally. I mean, I did some light checking online, but then it got taken over by the electronics manufacturing force in China. And if you check on eBay, there are many different versions of this available. And of course, depending on which model you buy, what accessories you get with it. But for $5, it's got to be pretty bad not to be worth it. So what is this device going to replace or supplement that as far as tools or instruments that I already have? Well, first of all, a trusty meter, of course. But and this meter will measure capacitance, and it's pretty accurate. It's made by Fluke, and as many of you are familiar with these instruments, it's an excellent instrument. Another thing I have is a component tester here, made by Peak Electronic Design. Bought this about 2 years ago on eBay, and it worked pretty well. It's pretty much the same as this, functionally it's supposed to be the same. Again, you turn it on, and the only difference is this doesn't have a socket, but rather 3 test leads to attach to the device under test. Now, I haven't used this in a while because, let's see if I can make this a little bit more clearly visible, but okay, so what happened with this? About 2 months after I got it, it started giving me that error message, and I had bought this through eBay too. I spoke to the, this is supposed to have like a 3-month or 4-month, 6-month warranty or whatever, and I tried to contact the eBay seller, Well, I did contact him and I said, look, this thing just broke. Replace it for me. And he said, any sort of warranty work, you need to contact the manufacturer in England. And that was that. Fine. I contacted Peak Electronics, and I did receive a prompt response, but what they told me was that error you're getting means that the embedded processor in it got fried. And most likely you hooked it up to a capacitor that had a large charge on it. And you have two options. You can either send us the device back and we'll repair it, but the repair would have been a significant amount of the purchase price. This was around $120. And it would take 6 weeks or more to make the round trip to England and get attended to. But in all fairness, the Peak did make the offer. They said, since the processor's fried, we are willing to send you a processor for free, and you can replace it. But, you know, it kind of seemed useless to me, because if it was true, I do not recall honestly having this hooked up and seeing a big spark on a capacitor or anything, or this thing warning me about it. But something went wrong with it, and getting a processor, waiting for it, putting it in, finding out that it still doesn't work is initially just throwing bad time after good time. No, good time after bad time. And I just figured at that point I'll just have to live without the component tester. But I think this guy should replace this, even though there's a huge price difference. Another instrument I have, which I bought shortly after I bought this, because I was impressed by how this was performing, was the Peak ESR Plus, which is a capacitance ESR meter. However, the problem with this is it worked fine for a while, and then it started getting an intermittent error in that whenever measuring a cap, it still measured the capacitance correctly, but a lot of times it would tell me that it had an ESR of 0. An ESR of 0 means that the capacitor is shorted. How can it even measure the capacitance and then tell me that it has an ESR of 0? Now, it doesn't always do this, but I think it's also on its way out, so I guess this will never be replaced by anything. But let's see if I can save myself a whole bunch of money and see how close this guy comes to the functionality of these. One thing I realized was with the way this test socket is arranged, and it also has this 3-terminal contact array here that you can press surface mount components onto. But, you know, anything that depends on your finger pressure is probably not a very accurate way to to measure something. So you should really do it through the ZIF socket. But, you know, the ZIF socket is ideal for a TO220 package like this. Also for small caps, resistors, anything where the leads are like this. But already when doing an electrolytic that has the different length leads on it, it already kind of gets weird getting it in there and having a secure connection. So what I'm going to do is, since there really isn't anything I can salvage from here, other than it does have these relatively high quality leads on it. So let me remove them from here and solder them underneath the socket, so I have yet another way to attach the device under test to this. So first, here's the inside of the Peak component tester. I did muck around with it, as you can see, because I ohmed out a few things, and essentially it runs off a AAA battery, and it has a buck converter here that generates, I don't remember, either 3.3 or 5 volts that powers the logic. And So my thought was, after I looked at everything, this is a CD4066 quad bilateral switch, which is connected to the inputs. And I figured that if a large voltage came in from a capacitor discharging or something, it would take out some of the passive components in its path, or the switch itself, and it wouldn't let the overvoltage get to the processor, which is a PIC something or other. So I did replace the 4066, damaging a trace in the process, as you can see, and fixing it with a bodge wire, but it didn't make any difference at all. Now obviously the processor is still running, since it is able to display a message on the LCD, but what I think happened is some of the GPIO pins that are connected, that the inputs eventually get to, I guess the voltage got through. This didn't burn out in an ultra-fast fashion, and so the damage got to the processor. So replacing the processor may have fixed it, but anyway, this is in the past now, and let's see if we got a replacement for it. So all I'm going to do is desolder these three leads here, which are the component leads, the test leads, and solder them to the bottom of the $5 tester. So I maintained the order of colors. Red is terminal 1, green is terminal 2, and blue is terminal 3. So we can either use this, or these guys to test. And let's start out with the basics. I have here a 47K carbon resistor, and we're going to hook that up between terminals 1 and 2 and see what it thinks it is. So it's telling us that it's a resistor, and it's measuring 45.9K. Okay, let's move the leads. Let's try the combination of leads here. Let's see if we do it between terminal 1 and 3. What will it say? Same thing. And lastly, between terminals 2 and 3. Okay, so that part works. But how about accuracy? So let's see what Mr. Fluke has to say. And Mr. Fluke says, $46.2K. Bit of a difference there. Whom do I believe? I don't know, but for grins, let's try a shitty meter. Even though this meter, I use this meter a lot because I'm not afraid of losing it. So it's unable, I mean, the AC part doesn't work very well on it. And let's see, how much does it think this resistor measures at? $46.3. So we got 46.2, 46.3, and what was that? 46.8? I don't remember. but using that data probably tells us that the multimeters seem to agree closer. 45.9. It's not that far off, actually. So we're okay with resistance. Let's get something a little bit bigger and see what that says. Okay, so now we got a 560K carbon resistor. And that one says 571. Using the meter I so flippantly called inferior. 565. And 571. Ballpark, none of these. I do not expect this to be extremely accurate, but if you have a big bag of resistors and you're looking for just the right value, they're all mixed, this will work just fine. So as far as resistance is concerned, pass. Next we'll use a 0.1 microfarad, which is the one I use mostly for bypass on logic chips. And what does that say? It tells us that it's 0.092 microfarads, about 8% off. Let's see what the fluke says. And it would probably help to use the right terminals. Test leads, I mean. Let's see, that's on capacitance now. That basically says it's 0.91 microfarads. That's pretty close. Now, I showed you, I have this guy too, but he doesn't go that low. I don't think he'll measure a 0.1. Let's give him one last chance here and see what he says. Yeah, so he can't go that low and is thus useless for smaller capacitance. All right, let's give him something he can handle. What we got here is a 10 microfarad 200 volt. On the Atlas. And tells us 9.8 microfarads and 2 ohms ESR, which is the right range. So it did work correctly, of course. Has to make a liar out of me. But let's see what everybody else has to say. On the $5, I keep calling it the $5 one. I don't even know what it's called. There's no name on here, is there? It's the Q2015-T3. All right. And this you can't read at all. And this you can't read at all either. Wait a minute, I just had it set up so you could read it. Yeah, that's better. So we got it going with the leads. And it tells us that it's 10.3 microfarads with an ESR of 0.96. The ESR is off by a factor of 2 as compared to the peak. And it also additionally told us that the loss factor is 0.6%. Okay, and finally, the fluke, which is still in capacitance mode. That one tells us 10.2 microfarads. The measurements are all well within the tolerance of the component itself, so I guess passed the capacitance test too. But let's get something a little bit larger. So here we got 2200 microfarads at 100 volts. And this one's going to take a little longer. It's waiting for it to time out. And it tells us that it's 2026 microfarads with an ESR of 0.12 ohms and a loss of 3.1%. So what does Mr. Fluke say? Mr. Fluke says, don't. Is he just like sitting here and waiting? Oh, there. Mr. Fluke says, about 2400 microfarads, and still within 10%, even though I guess the larger the capacitance is, the more of a variance we're going to see, but that's still good enough. So yeah, we're good on capacitance on the $5 tester. Next, we have a general purpose 2N3904, which is an NPN, and let's see what it says. NPN, 1 is the emitter, 2 is the base, and 3 is collector. Okay, and it also told us that the beta is 212 and UF 721 millivolts. I think what that means, it's supposed to be VF, and it's talking about the base emitter voltage here. I think. I looked it up and there were some discussions about it and I didn't find a clear answer, but I think that's what it means. So not only does it fit nicely into the test socket, but also seems to identify it quickly. Next we'll test a 2N3906, which is the complementary part to the 3904. So this is a PNP, and if the leads aren't pre-bent properly, but there you go. Identifies it, also has a beta of 252 and a VF of 662. So it's really good at measuring identifying and measuring simple transistors. But let's throw something a bit more complex at it. Well, before doing transistors, I should have done a diode, which I'm going to do now. This is a 1N4001. And Okay, so the forward voltage is 662 millivolts, and it shows a capacitance of 30 picofarads. This is kind of a pain making this. That's a little better. So it identified that. And next, let's try a Schottky diode. It should have smaller voltage drop. As 1/3 of the voltage drop, well, between 1/2 and 1/3 of the voltage drop of the 1N4001, and it shows a capacitance of 0 picofarads. So yes, it's able to handle diodes, and by looking at the forward voltage, you can tell the type of diode that you're testing. Next we have a tip 122. Now this is a Darlington, which means there's 2 transistors in there. The first transistor drives the base of the second transistor directly, and this is done so the package can handle more power. And let's see what this says. It's NPN, but it identifies it as a regular NPN transistor, and with a beta of 37. And that's because essentially, you know, the base, the part, it's measuring the base of the first transistor against the emitter of the second transistor, and I think the collectors are tied together. So it's actually measuring in between 2 transistors. So this is kind of a useless measurement, so he can't measure those. Now we're going to test a MOSFET. It's an IRF 530, and I hooked it up to the clip leads so we don't, because it was obscuring the screen. And yep, it properly identified this one. You can see it has the protection diode in there, and I guess from that it figures out that it's actually a MOSFET in there. And that's actually pretty impressive. Okay. Now that we are all impressed, let's throw something at it that I think it'll have a hard time with. So I won't be too surprised if this one fails. So what is this, you say? It's a triac. And with the way a triac is configured, probably would be a bloody wonder if it was able to identify that. But we give equal chances to every piece of equipment. And drum roll. Thinks it's a PMP with a beta of 8 and a base emitter voltage of 666 millivolts. Maybe that number, the 666, means something here. It's trying to tell us something, but oh, there you go. And for something a little more fun, Just a plain green LED. And we should be able to follow the test as this lights up. You can't see it on the camera. Oh, interesting. It did flash very faintly a few times, but it doesn't know what to do with it. That's interesting. Let's see. Let's try plugging it in a different position. Okay, it's now going from terminal 1 to terminal 3. There you go. Yeah, I guess I didn't... Something weird happened there. I don't know exactly which terminals I had it in, but yeah, there's the forward voltage. So that U definitely means it's supposed to be V. And 20 picofarads. So enjoy the little light show there. And there's your test. But of course I thought of one more thing. What about a voltage regulator? Now, knowing the structure of a voltage regulator, I really don't know what it's going to do with that. But what I'm guessing is it'll detect whether there's a short or open in the device. Or maybe it won't, because if there's an open somewhere, it maybe just detects it as a diode or... Well, let's see. There's a 7805 5-volt regulator in there. And it identifies it as an NPN transistor with an with a beta of 124 and a base to emitter voltage of 937 millivolts. So that was, I guess that's kind of expected, that the data it gives you is somewhat nonsensical, but I think it will identify whether you have a bad component. And for that, I mean, this is, well, it's a new part, so I'm assuming it's a known good part. But what if we use a known bad part? Here's a voltage regulator, an LM323K, that came out of the Atari Super Breakout PCB. That was bad. It had somewhat of a short in it, not a dead short, but enough to essentially create a really bad 5-volt rail on the PCB, around 2.5 volts or 2.1 volts. But let's see. So this is a bad guy, and if we test him, it thinks, then bugs out with the title, but does tell us that it's a bad part. So it's not very useful at identifying a voltage regulator, but if you know what the part is and you want a quick check to see if it's good or not, I think this will tell you very quickly whether it's good or not. Sure, you can just do diode measurements on it, but this is actually easier and quicker. There's lots more components we can test and see, but I think the point is made. I think I've shown you enough data for you to make up your own mind about the usefulness of this. So, what is my opinion? Should you get one? Yeah, I think you should. Bargains like this are just too few and far in between nowadays. This is a real bargain. It does work. I don't know for how long it's going to work. But even if you're doing any sort of electronics work, whether it's prototyping, design, or anything, or you scavenge parts and stuff like that, this is a great tool to have to identify things. One of the most useful things for me personally is every time I prototype something or draw a schematic, especially when I put transistors in, I always forget the pinouts. I always have to look them up, which, you know, if you're on your computer drawing schematics isn't a big deal, but if you're on your workbench and you don't have a computer close or whatever, you know, it's kind of a pain to have to look it up. You just take the components, stick it in here, and it will tell you the pinout immediately. That is probably, to me, as useful as its circuit, as its identification functions are. So even if you don't do any electronics work, I think you should still get one. This is just kind of neat. But anyway, I personally give this device a thumbs up, as I hope you will give this video. Leave me some comments, and make sure to subscribe so you don't miss the next one. See you on the flip side.